Today we are in section 2-4 and we are talking more about linear equations. In the last section we learned about slope-intercept form. Today we are going to learn about point-slope form. So it is the equation of a line that's written like this: y minus y1 equals m times x minus x1. So you're going to use point-slope form when you're given a slope and when you're given a point. So x1 and y1 is where you're going to plug in your point at, and again, m is always your slope. Let's look at example 1 on how we write an equation when we're given a point and a slope. We are going to write an equation of a line through the point 7, -1, and it has a slope of -3. So 7, -1 is my point that was given to you. 7 is my x value. -1 is my y value. So now we're going to use our point-slope form. So y minus y1 equals m times x minus x1. So again, the only place you're going to plug in numbers is for y1, m, and x1. The y and the x, you keep them the same. So I have y minus y1, which is -1, equals my slope, which was given right here to me, so -3, times x minus x1, which is 7. So now let's simplify this. Y minus -1 makes it +1. And I have nothing to simplify over here on my right hand side. So my equation in point-slope form is y plus 1 equals -3 times x minus 7. Now let's look how to write an equation of a line given 2 points. We are going to write an equation of a line that passes through -5, 0, and 0, -7. So I am going to go ahead and label my points x1, y1, x2, y2. Remember, it does not matter which way you label them as long as they are both x1, y1, and x2, y2. So since it does not give me a slope in this problem, we need to first find the slope. So yesterday we learned how to find the slope, so it's y2 minus y1 over x2 minus x1. So plug in my numbers, 7 minus 0 over 0 minus -5. So 7 minus 0 is a nice number of 7, and 0 minus -5, remember that makes it a plus, and that gives me +5. So now I'm going to write my equation in my point-slope form, so y minus y1 equals m times x minus x1. And it does not matter which point that you use. You can use the x1 and the y1, or you can use the x2 and the y2. They will look like different equations, but they are talking about the exact same line. So I'm going to start with my x1 and my y1. I'm going to show you both of them. So y minus 0 equals 7/5 times x minus -5. So y minus 0, you don't need to write that because it's just minus 0. So you can simplify that to just y. And then 7/5 times, and then minus and a minus makes it x plus 5. So now I'm going to use x2 and y2 to show you that either way you can write it. It doesn't matter which point you choose. So if I use my other point, I'm going to be using y minus 7 equals, it has the same slope, 7/5 times x minus 0. So y minus 7, I can't simplify that anymore, so it stays y minus 7. And then x minus 0 is just x. So either way, if you gave me this as your equation of a line or this, they are talking about the exact same thing. Another way to write the equation of a line is in standard form, and that equation is ax plus by equals c. So something for you to notice: x has to come first, then y, and on the other side of your equal sign is the letter c. So we must make a positive, and then a, b, and c cannot be fractions or decimals. Let's look at how we write the equation of a line in standard form now. We are given the equation y equals 2/3 x minus 4. And if you notice right now, that's in slope-intercept form. 2/3 is my slope, -4 is my y-intercept. And standard form, it is ax plus by equals c. So I definitely need to move my x to the other side. So since it's positive 2/3 x, I am going to first subtract it. And I'm going to write it out in front because that equation shows it coming first. So I have -2/3 x plus y, because it was a positive y, equals -4 now. So on the other side, I told you that we couldn't have any fractions. So I need to get rid of my denominator, that's 3. So what would make that denominator go away? If we multiply everything by 3. So 3 times -2/3 x gives me -2x. And then we need to do 3 times y, which gives me 3y. And then we need to do 3 times -4, which gives me -12. Now, on the other side, I also said that x had to be positive. So up here, if you multiplied by -3, it would have made that positive. Or we can come down here to the bottom, and if we multiply everything by -1, it'll also make it positive. So that gives me positive 2x minus 3y equals positive 12 now. And this is your equation in standard form. Now let's look at how we write this in standard form when we are given a decimal. So I have y equals 9.1x plus 3.6. So let's first bring our x to the other side because it needs to be in the form ax plus by equals c. So since it's positive 9.1, we are going to subtract 9.1. So that gives me -9.1x plus y equals positive 3.6. Now we need to think about what number could we multiply by that would get rid of these decimals. How would I get rid of that 0.1 and that 0.6? I need to just scoot my decimal point over 1, and then that would make them whole numbers. So to just scoot it over 1, if I multiplied the whole thing by 10, it will get rid of that decimal. So 10 times -9.1 gives me -91x. 10 times y gives me 10y. And 10 times 3.6 gives me 36. Look, now I have all whole numbers. So now you need to check, is your x value positive? And it's not. So again, if I multiplied by -10, that would have done it at the same time. Or you can just wait until the end, multiply by -1, and that gives you positive 91x minus 10y equals -36. And that's your equation in standard form. So now let's look at how we find the intercepts, and this is going to help you graph. So if I look at this point over here, this is my x-intercept. It's where my line crosses my x-axis. So let's make this, for instance, positive 3. So my x-intercept is 3, 0. And if you notice, I have a 0 in my y part of my point. So now let's look at my y-intercept. It's where my line goes through my y-axis. And again, if I give this a number, let's make that -2. This is the point 0, -2. If you notice that there is a 0 in the place of my x part of my point. So to find the y-intercept, if you're given an equation, you're going to plug 0 in for x. To find the x-intercept, you are going to plug 0 in for y. let's look at how we graph this, finding our x and y intercepts. So if I give you 2x minus 4y equals 8, if you notice, that's in standard form, and in standard form, the easiest way to graph it is to find your x and your y-intercept. Of course, you could write it in slope-intercept form, and you can graph it that way as well. Sometimes this is just easier. So if we want to find our x-intercept, we have to plug 0 in for y, because I want to see where it crosses my x-axis. So -4 times 0 is 0. So I have 2x equals 8. And then if I divide both sides by 2, I have x equals 4. So my x-intercept is the point 4, 0. Now let's find our y-intercept. So to find our y-intercept, we are going to plug in 0 for x because I want to see where it crosses my y-axis. 2 times 0 is 0, so I'm left with -4y equals 8. Divide both sides by -4, and so that gives me y equals -2. So this is the point 0, -2. Let's graph those 2 points. So 4, 0, 1, 2, 3, 4, put a dot. 0, -2, put a dot. As long as you have 2 points, that is enough to make a line, so we just connect them. And your graph looks like so. Now let's talk about parallel lines. So parallel lines are never going to intersect, and their slopes are the same. Their slopes being the same allows them to never intersect, but if you notice, their y-intercepts are going to be different. Perpendicular lines are going to intersect, and they actually make a 90-degree angle where they intersect. So these slopes are negative reciprocals of each other. So an example of a negative reciprocal, if I gave you let's say the blue line had a slope of -2/3. If you notice, that line does fall from left to right, so it does have a negative slope. And if you notice the pink line, it has a positive slope. It rises from left to right. So the negative of -2/3 is going to be positive, and then the reciprocal of 2/3 gives me 3/2. So that is the negative reciprocal for the perpendicular lines. So I want to write the equation of a line that is parallel to 4x plus 2y equals 7, but I want it to go through the point 4, -2. So I first need to look at my equation, 4x plus 2y equals 7. And since it's not in slope-intercept form, I cannot determine the slope right now. So I'm going to take 4x plus 2y equals 7, and I'm going to solve for y so I can find the slope easily. So I'm going to subtract 4, so that gives me 2y equals -4x plus 7. And then I'm going to divide everything by 2, so that gives me y equals -2x plus 7/2. So now I can easily determine that my slope is -2. You don't care about the 7/2 at all because you want it to go through this new point of 4, -2. So since we're talking about parallel lines, we are going to use the exact same slope. And since it gives me this point, 4, -2, we are going to start by using point slope form because we know a slope and we know a point. So let's plug in y1 and x1. So that's going to give me y minus -2 equals, I'm going to use my same slope because I want it to be parallel, x minus 4. So now let's simplify this. So that gives me y plus 2, and then I have nothing to do on my right-hand side. So that is your equation of a line that is parallel to 4x plus 2y equals 7, but it also goes through the point 4, negative 2. So from that equation, I could write it in slope-intercept form. So to write it in slope-intercept form, I'm going to have to start by distributing my 2. So negative 2 times x is negative 2x. Negative 2 times negative 4 gives me positive 8. And then to get y all by itself, all we have to do is subtract 2. And you're only going to subtract it from the number, so that gives me y equals negative 2x plus 6. Again, that equation is parallel to 4x plus 2y equals 7, but it still goes through the point 4, negative 2. Now let's look at writing the equation of a line that is perpendicular to y equals 2/3 x minus 1, but it also goes through the point 0, 6. So if you look at the equation that's given to you, this is already in slope-intercept form, which means I can easily determine what my slope is. My slope is the number that's in front of x, so it's 2/3. So perpendicular lines do not have the same slope anymore. It's the negative reciprocal of the given slope. So I'm given 2/3. The negative of 2/3 is obviously negative. And the reciprocal of 2/3, flip that fraction over, gives me 3/2. That is the new slope I'm going to use. So again, now I am given a slope, and I want it to go through this point. So I am going to use my point slope form, y minus y1 equals m times x minus x1. So 0, 6, this is x1, this is y1. Let's plug them in, plus our new slope that we just found. So y minus 6 equals negative 3/2 times x minus 0. Let's go ahead and let's simplify that now. So y minus 6 equals, and then x minus 0 is the same thing as negative 3/2 x. Now this problem's really easy if I asked you to put it in slope-intercept form. All what you would have to do is add the 6 to the other side, and you would get y equals negative 3/2 x plus 6. So it is perpendicular to the line y equals 2/3 x minus 1, but it also goes through the point 0, 6.